Hello and welcome. In this video, we are going to take another look at the basics behind web development and networking in general. And in this video, we are going to focus on the Hypertext Transfer Protocol, also known as HTTP. Now, this is not meant to be a comprehensive look at the HTTP protocol, but rather an overview so you can understand how it relates to both web development and networking. So to begin with, let's look at what HTTP is and what it is not. Now, we are referring to the application layer protocol that defines the communication between the client and the server. The client being your web browser and the server being the web server and potentially other resources, but specifically the web server. It is not, or rather does not, refer to the HTML language or any of the other code that we are going to write that may reside on either the client or the server. It focuses solely on the communication between the client and the server. Now, originally, it was designed by Tim Berners-Lee and CERN and originally released in 1989 or 1990, depending on what you use as the origin point. And again, it is meant to focus on the application layer of the OSI model. Now, there were a couple of versions that are now obsolete. If you look at the history of it, particularly the transition from 1.0 to 1.1, basically what happened was instead of having multiple communication channels or multiple TCP pipes open between the client and server, it was refined to where it would only require a couple of TCP connections between the client and the server. Further refinement then from 1.1 to 2 allowed for some improvements in the encryption, or rather, excuse me, the compression, not the encryption, but the compression of the metadata that was sent between the client and the server. And then lastly, HTTP 3 focuses not on the TCP protocol, but rather uses the UDP protocol, which represents a functional shift in the interaction between the client and the server. All of the older versions of HTTP, including the ones that are obsolete, all relied on TCP, which is a connection-oriented transfer protocol, but rather UDP is connectionless. Now, it doesn't mean that HTTP 1.1, 2 are going away, but rather they are intended to rather complement each other, although the majority of the websites that are now hosted currently are going to be focusing on HTTP 2. The other thing that we aren't going to spend a lot of time talking about yet is going to be the HTTPS, or Hypertext Transfer Protocol Secure version of HTTP, which is essentially just an extension of the original HTTP protocol that supports TLS encryption for secure communication. TLS is an encryption protocol that is leveraged with the transport layer, and specifically, it's a cryptographic protocol. In other words, basically what it does is it allows for secure communication between the client and the server. And again, as I've already mentioned, the HTTP protocol fundamentally uses a client-server distributed model of computing. Now, before we go any further, I just want to point out that the client, again, is your web browser. Doesn't mean that there's necessarily any significant difference between the resources on the client and the server. It's more of a functional, or rather a role. Although typically speaking, your web server does in fact have more resources. So the server then might be considered then some sort of server with some sort of computer rather with a higher amount of RAM, redundant power supplies, and so on. We talk a little bit more about that in an earlier video. Instead, what we want to do is we want to continue to focus just solely on the HTTP protocol. And the next thing that we want to look at is that metadata that I alluded to in the change between HTTP 1.1 and 2, where I mentioned the compression of the metadata. Well, what kind of metadata are we interested in? Well, in an earlier video, we took a look at the full URL, including the protocol, the domain, the path, and then we took a look at something called a query string, and we talked a little bit about the data that would be transferred back and forth. Now what we want to do is we want to look at the headers that comprise the metadata that is passed between the client and the server, and also from the server back to the client. And so essentially what it is a list of strings that are sent and received by both the client program, in this case the web browser, although technically not exclusively a web browser. We'll take a look at a later video how you can actually emulate the web browser's behavior, and the server upon a TCP, or excuse me, rather an HTTP request and response. We're going to take a look at both categories. There is the request headers that go from the client to the server. And you can see here that I've listed some of the fields or some of the request headers that you might encounter. Some of the basic ones, for instance, are going to be the host and the user agent. The host just simply specifies the domain name and the optional port that is associated with a particular URL. If you recall from an earlier video, I explained that in some cases you don't need to provide the port number. It's just simply the default port. But again, if you have your web server or web resource on an alternate port, you will need to provide that. The user agent just simply tells the server what type of client is attempting to connect to the web server. This can be used to control the behavior, or rather the response back from the server to the client. The accept encoding simply tells the server what media types the client expects, as well as the encoding and the compression that is accepted. The connection, which is somewhat of a deprecated feature, it's not available in the HTTP 2 or 3 protocol. This tells you whether or not to leave the connection between the client and the server open. Please note that the server may still choose to close the connection. This is just simply part of the request to the server. And a couple of other things like the cache control simply controls how often the data from the server will be updated to the client. There's a number of control directives that we'll take a look at in a later video. And then the content encoding and the content link simply tell you how you are sending the data to the server. And we'll see that some of these headers exist both in the request from the client to the server, and we'll see in just a second, they also exist in the response back from the server. Now, there are other request headers. These are just some of the more commonly used ones, or the ones that we're probably going to encounter and probably work with. And again, the web browser does a lot of this for you. If you are familiar, if you're interested in working with a language that will allow for you to customize an HTTP client, you can actually set some of these fields. And again, I'm going to take a look at that in a later video. Now, moving on to the response headers, basically these are the headers that are then sent back with the data from the server to the client. Again, you can think of this as metadata. This isn't necessarily anything you see or will be presented to you in your web browser or rendered in your web browser. We'll see in just a second how we get access to this information, but things like the server name, the last modified for the specific resource that has been sent from the server to the client. A couple of other useful fields are going to be the content length, the content type, as well as the content encoding. All of that focuses on the content and data that is coming from the server back to the client. Specifically, the content length may be helpful if you are trying to do some sort of asynchronous process on the client. And then another useful one that we might encounter is just simply the set cookie response header, which essentially then provides for you a cookie that will be then stored on the client. Now, you'll notice here that I have a couple of links. If you go back for just a second, you'll notice that the hyperlinks for the HTTP header fields are broken into the request headers as well as the response headers, and those are just our regular Wikipedia articles. But I'm also providing you some additional resources in this presentation, and that is from the MDM, or the Mozilla Developer Network. They are a very good resource for web development. They will go into a little bit more depth than what the Wikipedia articles or a textbook would. But more importantly, they will also provide you with some examples. So I encourage you to take a look at these links for the MDN or the Mozilla Developer Network. Now, moving on, we're again still focused on the communication protocol between the client and the server. And so we're once again back on the client. The client is going to be making requests of the server. And you could sort of think of these requests as verbs or potential actions. In other words, how can the client interact with the server? Well, the first and arguably the most common interaction between the client and the server is, well, as it sounds, just simply to get a resource from the server. And that is, in fact, what we'll see is the request method. We're actually going to be working with several of these methods, but the get, post, and put are probably the three most common ones that we'll be working with the get, simply getting the target resource from the server. The head does something similar to the get. It does that, but without retrieving the data from the server. It simply provides you then with some of the metadata that would be seen in the headers. The post simply requests the target resource being processed on, and the way that, in the representation enclosed, well, that's just simply a fancy way of saying that you're wishing to add something. And again, we're going to have to write code on the server to be able to facilitate each one of these potential actions. But the post and put, they're both very similar in that they both request that the target resource get added, or in the case of put, updated. In other words, it's updating an existing resource on the server. The delete, well, the delete just simply requests that the target resource be deleted. And the patch, which is one that's a little more complicated, and it's essentially just a partial update of a resource on a web server. And again, you can see here that I provided you with not only the Wikipedia link and the partial descriptions of each one of the request methods, but also the Mozilla MDN web docs for the HTTP request methods. Now, in just a second, we'll actually take a look at how you can understand the metadata that goes along with a request from the web server and the response back from the web server. But before we get there, let's take a look at one more aspect of this. We have the communication protocol, we have the request and the response fields, we have the verbs or the actions that can be taken on the server. But then the last portion or the last piece of this is the response back from the server. In other words, basically you request to get something from the server, and in addition, hopefully, to getting that resource, you are going to be provided with some metadata about the interaction with the server. And these response codes can be used in a number of ways. They can be used in debugging your interaction with the web server, or at the very least, then it will control the browser's behavior. In other words, for instance, if you can't get access to a specific resource. And these response codes, these response status codes, come in sort of ranges of values. And instead of thinking of this in terms of severity, what you want to do is you want to think of these response status codes as the further you get along in the process can be determined by the level of the response status code. In other words, a 100 level response is generally pretty early on in the process. A 200 level response is going to be, again, another step in the process. And so, for instance, the 100 level response then is just simply to acknowledge that the request was received, and you are continuing to process, but it doesn't mean that anything was actually done. In other words, the request from the client to the server was received. Anything with a 200 response status code then indicates the request was successfully received, understood, and accepted. 300s, which we really won't spend a ton of time on. If we get an opportunity to, we'll look at some redirections, but that's if a resource has been moved, might sit, for instance, on a different server or in a different location on the server. Again, we aren't going to spend a ton of time with that, but the 400s and 500s are a little more interesting. Specifically, the 400s, that means that there's some sort of error on the client. The request contains some sort of bad syntax or cannot be fulfilled. And the 500 series then focuses on some error on the server. The server failed to fulfill an apparently valid request. Now, before we go any further, I'm actually going to pull up the response codes, and I'm actually going to show you some tools about how you can actually see these response codes in action, and also the headers themselves. Thought I would point out probably the most common or the most widely known response code, and that's just the HTTP 404. And that just simply means that the browser was able to communicate with a given server, but the server could not find what was requested. I only pick on this particular code because that's probably one that has managed to make its way into pop culture. In other words, something that people that aren't necessarily technical even recognize this particular code. All right, so let's go ahead and take a look at some of the error codes in just a second, or rather the status codes. And you can see here, I'm again pulling up the Wikipedia article. We could also look at the MDN article, but you can see here that some of the informational responses continue, switching protocols and so on. And we'll take a look at a few of these, but I'm going to point out just the most common or the most interesting ones, the ones we're most likely to encounter. And that will be, for instance, the 200, which simply indicates that it's okay. It's a standard response for a successful HTTP request. And again, you can see here that these are various levels of success. However, though, for instance, like 204, the server successfully processed the request and is not returning any content. Doesn't necessarily mean that there was necessarily an error or a problem. It just means that a 200 level status code will still indicate success, but it does not necessarily imply that there were any results returned. Again, we'll take a look at the 300 levels if we get an opportunity to in another video. The 400 levels are probably the one that we're going to encounter the most, specifically the 400 bad requests. In other words, the server cannot or will not process the request. 401, which is unauthorized, similar to the 403, but basically usually indicates some sort of authorization or authentication problem, perhaps some sort of security issue on the file server, on the web server or the file server that might be supporting the web server. 404 not found. The requested resource could not be found, but may be available in the future, and so on. And then also, you may have encountered some of the 500 level server errors. Usually the most ambiguous one is the internal server error, and that is just simply a generic error message given when an unexpected condition was encountered. Sometimes, though not exclusively, that happens when there is an application on the server that crashes or has an exception thrown that is not properly handled. The 501 not implemented usually refers to some sort of path where you have a web service API that maybe, for instance, a verb was not fully implemented or a feature was not implemented. Bad gateway where the server is acting as a gateway or a proxy and received an invalid response from the upstream server, and then so on. Again, we're going to take a look at some of these error codes. We cannot feasibly cover all of them, but you just want to be aware of these error and status codes and how they relate to the HTTP protocol and specifically the metadata, which brings us then to the last topic that we want to talk about, and that is the tools that we are going to use to potentially identify the metadata and triage the metadata or troubleshoot our web services. And there's a couple of them. First of all, and the one we're going to see is going to be the web browser development tools, the plugins that we can use. We're going to use Google Chrome in this particular example, but Microsoft Edge and Safari and Firefox all have them as well. Postman is one option that will allow for us to view HTTP or HTTPS traffic. That essentially works well with things in the application layer. It is not limited just simply to the HTTP and HTTPS traffic. You'll see that we can actually use that for a number of applications. And the other tool that you may already be familiar with is Wireshark, which allows for you to view the TCP and UDP traffic directly. And that works well for troubleshooting things at the transport and network layers. Additionally, your IDE, such as Visual Studio Code, and NetBeans will also have some plugins that will facilitate web development. That, again, these aren't used in isolation. If anything, you kind of use all four of these tools depending on what you're trying to troubleshoot. Wireshark is, of course, going to focus a little more on the networking side of it. Postman will allow for you to send and receive responses from a web server. Essentially, it's going to be acting like a proxy client or a web client to connect to the web server. And then what we're going to see in just a second with the web browsers themselves, they can actually troubleshoot and essentially give you access to this metadata. So let's finish off this video with a little bit of an introduction into how you can use the development tools that are in your web browser. You'll notice that I again have my Google Chrome here, and all you simply want to do in this case is go up here to the tools, go to more tools, go to the developer tools, and you'll see that another window pops up. Again, this is going to be kind of small in this video. It might be a little hard for you to read, but what you will notice here is that I now have a whole bunch of other options that we will again dive deeper into in a later video. What I want to do is I want to make sure and select this network tab. So take a second if you need to pause the video to find the networking tab, depending on how your browser is laid out. And then what I want you to do is I actually want you to go ahead and refresh your web page. And in this case, I'm actually looking at the page that is the list of HTTP status codes. If anything, that's kind of ironic here. And so you'll see that now suddenly we've populated the network tab rather effectively here. And you could see here that right off the bat, there is a whole bunch of status 200s. And for each of these rows, if you click on them, you can actually see the request URL, the request method. In this case, it was a GET. We were trying to simply get the information from Wikipedia for this particular page. The status code is 200. That means we were successful with it. You can see things under the response header, for instance, like the content encoding, and that refers to the compression. In this case, it's gzip. The content language, which was, again, one of these metadata fields that we didn't talk about. There's quite a few of them. You can see the content length. And you can also see down here the request headers. So this was the request made by the client to the server. This is actually kind of backwards if you think about it. This is the response header. This is what came from the server to the client. And then the request header is what came from the client to the server. In other words, the method that was sent was the GET method, the path, the scheme, in this case was HTTPS, because the Wikipedia site is functioning on HTTPS. You can see here that there's also the encoding that we will accept, the language that we will accept, any cookies, and the user agent, which we will dive into a little bit further, that essentially tells the Wikipedia web server what type of client we have. And again, you can simply go down through each of the rows here. You'll see that there were actually multiple requests made of the Wikipedia web server. You could see here that there are some PHP scripts that were loaded. The PNG for Wikipedia itself, if you were to come up here, I'm not sure if the way this is resized, if we're going to see it, but it's referring to this image right here, wikipedia.png, and so on. And you can, again, just go through and see a number of these, which we will, of course, dive into much, much deeper. So hopefully you found this video useful, a little bit of an introduction to the tools that are going to be at our disposal. Again, I would encourage you to go ahead and download Postman and Wireshark as well, and get familiar with whichever web browser you're going to be using. And if nothing else, then make sure that you can pull up the status codes associated with a particular website. It doesn't necessarily have to be the Wikipedia website. This just happened to be a nice, relevant one. So as always, if you have any questions, comments, or concerns, don't hesitate to reach out to me. And thank you for watching.